Hello and welcome to another one of these ADD videos. Today we're going to look at part 2 of the Introduction to Organic Chemistry and briefly touch on Lewis structures. Again, this is a light review. If you want anything more in depth, I've got a few videos on the Gen Chem site that there's one concept video and I believe 2 or 3 example videos where they progressively get more and more difficult. But what is the concept of Lewis structure? It's a way of looking at our valence electrons and how they pair up in the different types of bonds. Basically, if we have an element, we put the valence electrons one at a time on each side, top and bottom, and then start pairing up. And a pair of dots, as in a bond, would be represented as a straight line. So what are the steps? Well, let's look at some of the steps for Lewis structure. What you got to do first is get all the valence electrons, and the way you do that is you look at your periodic table. Where did I put my periodic table? Where you at, little guy? Did you way back there? There you are. And you can get the valence electrons based off the group that they're in. So 1, 2, 3, 4, so forth and so on. Okay. After you get the total number of valence electrons, make sure you account for the subscripts as well, right? So if it's CH4, there's 4 hydrogens, so it'd be 4 times 1.008 and so forth. Just for the ions. A cation, what is a cation? Well, a cation basically is something that's an element that's lost an electron. And what you're going to do with the cations is you're going to take your, it's going to be +1 or +2 after the plus sign, right? So you're going to take that number that's after the plus sign and subtract it from the total number of electrons. Okay. If it's an anion, Facebook message, sorry about that. If it's an anion, it's a gain of electrons, and we're going to add the number after the minus sign to the total number of electrons. After you get the total number of electrons, we need to draw a skeleton structure. And the skeleton structure consists of all the elements with the least, again I repeat, the least electronegative element in the center. Every once in a while, due to symmetry, stuff like that, there's exceptions to the rule, but basically it's the least electronegative element. All right? So then you draw all the bonding electrons. So start with a single bond in between the elements. And however many of those you draw, you're going to subtract from the total number of electrons to get your lone pair electrons. And then you should draw on your lone pair of electrons to complete the octets, and the number of total electrons you have should match the number you drew. If not, something's wrong in your structure or where you put the bonds, or we need to add a double or triple bond to make it work. Okay. Now, expanded octet is possible if your central atom is on or below the 3rd row, okay, of the periodic table. That's due to the fact that once we get to the 3rd row, we have all these orbitals found, the 5 orbitals in the D subshell. So once you've got a plausible structure, it doesn't necessarily mean it's going to work, okay? You might even have 2, 3, 4 structures that do work, that fill all these criteria. What you want to do is you want to get the least number of charges, have to have full octets, so disregard it if it doesn't have a full octet for carbon, for instance, and we want the most number of bonds. So if we have double versus single bonds, go with the double one. All right, and that's basically the steps for Lewis structure. I'm not going to do an example. If you want to go through the examples, just check out the example videos under the Gen Chem. I'll try to put a hyperlink for that as well in the section below. All right, so that's basically it for Lewis structures, and the next thing I'm going to go over is bonding, the different types of bonds that you're going to find on your interaction between elements. So we're going to go through single bonds, double bonds, triple bonds, as well as ionic versus covalent.